Today we have very important topic that has many applications in different industries, and we used to apply that concept usually in the laboratories, and that is about the concept of acids and bases. Okay, acids, as we know, acids are usually those substances which actually produce hydrogen ions in the solution or in water, whereas bases are those compounds which increase the concentration of hydroxyl ions, those OH ions, and acids are those compounds on dissolving in water, they usually increase the concentration of hydronium ions. Okay. Now the concept of acids and bases can be explained by using three different concepts. Okay. One of them is acids and according to this concept or in this concept, acids are those compounds. Acids are those compounds while dissolving in the water, they can produce hydronium ion. Hydronium ion. We call it hydronium. Whereas this hydronium ion is actually a water and H plus ion. Okay. Collectively we call it hydronium ion. It is actually H ion. Okay. So the acids are those compounds which will produce hydrogen ion when we dissolve that compound in the water. Okay. For this particular concept, the presence of water is important. Okay. And base is that compound which will increase the concentration of hydroxyl ion in water. Okay. According to this concept, arsenous acids are those acids which produce hydrogen ion in a solution when they are dissolving in water. And bases are those compounds which will produce hydroxyl ion when these compounds are going to dissolve in a water. For example, suppose we have HCl. Okay, and we have water. When we dissolve this HCl or this compound, water, it will give you hydronium ion and nitric ion. Because this compound is producing hydronium ion, so that we call it this is an acid. Similarly, if you have sodium hydroxide, okay, and you are going to dissolve in water, it will give you sodium ion and hydroxide. According to these two equations, this acid, this compound is going to produce hydronium ion, and this compound is going to produce hydroxyl ion. So that this compound is called base and this compound is called acid. According to our previous acid and basis concept, acids are those compounds which will give you hydrogen ion, whereas base are those compounds which will give you hydroxyl ion. Okay? Now we have another concept that is called bronzed forming acids and bases. Okay. According to this concept, acids are those compounds which will donate proton hydrogen. Okay. And bases are those compounds which will accept proton. Okay. Acids will donate proton, that is hydrogen ion, and bases will accept proton, that is hydrogen ion. For example, in case of acid, suppose you have this HCl and you have water over here. Okay. Actually, what will we are doing over here? This proton will be given to water and it will give you hydrogen ion, and here you have Cl. Because this compound is providing or donating hydrogen ion to water, so that we call it acid. Okay. In this way we call it HCl is an acid because it has the ability to produce or to provide or to donate hydrogen ion. Okay. In similar way, this HCl is called acid because it has the ability to donate proton. Similarly, suppose we have hydroxyl ion, and here you have hydrogen ion, and it will. Okay. In this case, this OH active will be called base because it has the ability to accept this proton. Okay. It has the ability to accept this proton, so we call this hydroxyl ion as a base. Okay. So, according to Bronsted-Lowry concept, acids are those compounds which will donate proton, and bases are those compounds which will accept proton. Okay. And now is use acid and bases. According to this concept, acids are those compounds which usually accept lone pair or pairs, and bases are those compounds which will donate lone pair. Okay. As we know, suppose we have oxygen, and over here it has 8 electrons and its 16 is mass number. When you are going to write its electronic configuration will be 1s2, 2s2, 2p4. Okay? You can write like this. 1s, 2s, 2px, 2py, 2pz. Okay, 2, 3. Okay, in valence shell, these two are non-bonding electrons. So we call them non-bonding electron. These non-bonding electrons will act as lone pair, because in case of oxygen we have two non-bonding electrons. So oxygen has two lone pairs, into those electrons which will not contribute in the bonding. Okay, these are the non-bonding electrons. So oxygen has two lone pairs. So we have to deal with lone pair over here. According to this concept, acids are those compounds which has the ability to accept that lone pair, whereas bases are those compounds which has the ability to donate that lone pair. For example, we have what we call post NH3 plus Bm. In this case, this lone pair is available in this compound. It has the ability to donate this lone pair to this compound, and we will come up with and B. So in this particular example, this compound is actually donating one lone pair. So this compound will act as base, whereas this compound has the ability to accept electron, so we call it acid. Because the concept of lone pair is actually dealing with the Lewis acids and bases. So this compound, it has the ability to donate lone pair. So we call it Lewis base, and this is actually accepting that lone pair. It has the ability to accept the lone pair. So this compound is called Lewis acid. This is okay. These are the three different concepts. We have 2 or 3 more concepts to explain them actually. What are the acids and bases, but we will rely only on these 3 concepts particular for your course. Okay. According to Arrhenius concept, when you are going to dissolve a compound in a water, if it will give you the hydronium ion, you call it acids, and if it will produce hydroxyl ion, you will call them bases, because they are following the concept of Arrhenius, so you call them Arrhenius acids and bases. Now, the other concept is Bronsted-Lowry concept. According to this concept, acid will donate proton and base will accept proton, whereas the last concept is the Lewis concept. According to this concept, acids are those compounds which has the ability to accept lone pair, whereas bases has the ability to donate lone pair. The parameter which is the responsible to measure the acidity of acid or basicity of base, and that is the only one parameter, we call it pH. Okay. While measuring the value of pH, we will be able to explain the strength of acids. Either it is weak acid or strong acid on the basis of their pH. Before going to pH, the concept of pH, I will explain the strength of acids and bases. Okay. Strength means either acid is a strong or weak, either the base you are using is strong or weak base. The strength of an acid or base is mainly dependent upon their ionization. We have, suppose I am talking about strong acids. And here we have weak, strong acids are those acids which will ionize completely. Okay? Whereas in case of weak acids, these acids are ionizable on a limited extent, or ionized in limited extent means not completely ionized. Those acids which will ionize completely or which can be ionized completely, we call them strong acids, whereas weak acids will not be ionized completely. For example, suppose you have, in this case, you have HCl, H2SO4, nitric acids. These acids have the ability to ionize completely. They will be ionizing completely. Okay? And weak acids, for example, I will give you one example, acetic acid or benzoic acid, oxalic acid, or all organic acids are weak acids. They will not be able to ionize itself completely. Okay? Means when they are going to ionize, when you have strong acid, they will ionize completely. Suppose you have HCl. This is HCl. When it will ionize, it will give you hydrogen ion and silver ion. After ionization, you will have no content of HCl compound. You will have only hydrogen Cl line. It means this HCl is ionized completely. Whereas in case of weak acid, suppose you have this weak acid HF, and after ionization you have few content of HF, few content of H plus, and some content of F. So this you have seen over here. This compound is not completely ionized into hydrogen fluoride ion. After ionization, you have some amount of AHF, original compound as well. So this acid is ionized completely, so we call it strong acid, and this acid is not ionized completely, and you call it weak acid. Weak base and strong base. Completely ionized, limited ionization, or not hydroxide, potassium hydroxide, calcium hydroxide. Whereas weak bases, I will give you very simple example, ammonia. Okay, ammonia is a weak base. Okay, so these acids, such type of compounds are actually can completely ionize, so we call them strong base, and this such type of compounds cannot be ionized completely, so we call them weak base. Okay, so these are the actually strength of acids and bases, and the strength of acid and or base is mainly depends upon its ionization. Okay, ionization is the process where a compound is the phenomenon where a compound is actually going to be ionized. I mean, suppose you have this sort of compound A. It is hydrogen and it's anion. So when you are going to ionize, it will give you hydrogen and A-. This sort of process is called ionization. Conversion of a compound into its ion is called ionization. Okay. Similarly, if you have a base, so sodium hydroxide, then it will be ionized into sodium and hydroxide. Similarly, if you have HCl, okay, after the ionization, it will give you H plus and Cl. So the conversion of any compound into its ion is called ionization. And those compounds, either it is acid or base, if it is completely ionized, you call it strong, either it is acid or base. If it is not completely ionized, then it will be. Strength of acid and bases can also be explained while using the concept of pH scale. Okay, pH scale. What is actually pH? pH is a mathematical expression that is minus logarithm of hydrogen. Okay. After this calculation, by applying the concept of logarithm or number of ions or concentration of hydrogen ions, we will come up with a number. That number is actually will give you the value of pH. Similarly, this concept is for acids. Okay, pH is equal to minus log of hydrogen ion, and we have pH scale is from 0 to 14. Okay, and in between you have 7 spores. You start from here to here, and here you have 7, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. 7 means neutral. Above this, you have bases, and below this, you have acids. Okay. Here you have V2. Sorry, here you have strong 2 up to now, weak acids, and here you have V2 strong bases. Okay, from left to right up to 7. If any solution has pH 7, you call it is neither an acid or base, it is a neutral solution. If the solution of pH is below 7, then you call it acid. If it is near to 0, then you call it strong acid, and if it is near to 7, you call it weak acid. Okay, means if two solutions, one of them has pH 2, another has 5, the solution which has pH 2 will be the stronger acid, and whereas the other which has pH 5 will be the weaker acid. Similarly, here you have bases. This solution with pH 8 will be the weak base. Okay, and solution with pH 13 will be the strong base. Okay, and for acid we have to write pH, whereas for bases we used to write POH. POH minus logarithm of hydroxyl ion percentage. Because bases using coordinates concept, bases will give you hydroxyl ion and acid will give you hydrogen ion. So on the basis of that concept, pH is equal to minus log of hydrogen ion. This H will indicate you will have to write a concentration of hydrogen ion, and this OH will indicate you will have to write a concentration of hydroxyl ion. And this concept is actually pH plus POH is equal to 40. Okay. If any solution has pH 6, then you will be able to find the value of pH. If its value of pH you have to know the value of pH. For that, we need to find the value of pH. Okay, and if you want to find the value of pH, you must have to know what the value of pH. In the laboratory, we usually have pH meter to find the pH of the solution. What will you do? You will have the pH meter and you will have the solution. You will dip that pH meter, the cell of that pH meter. Okay, we will dip into the solution. It will give you the pH of the solution. That will give you a number ranging from 0 to 14. If it is near to 0, you will call it strong acid. If it is near to 14, you will call it strong base. The other way is the pH paper. We have pH paper as well. Okay. Okay. We have pH scale and then pH meter and pH paper. pH paper will also give you the estimation of pH of the solution. In pH paper, usually we have orange or yellow in color. If you are going to dip that paper into the solution, if that paper turns into red color, you call it the solution which has the ability to turn that pH paper, the color of the solution has changed the color of pH paper into red, you call that solution is acid. Now if that paper is changes to blue color, you will call it the solution which is actually going to change the color of that pH paper into blue will be the base. Okay, this is the concept of pH scale, pH meter and pH paper. These all concepts used to determine the strength of any, to study the salt reaction of acid and base. Okay. Whenever you have an acid and you are going to study the reaction of that acid with any base, okay, it will give you a salt. Okay. If you have strong acid, suppose sodium, you have base, strong base, sodium hydroxide and acid HCl, they will react to give you sodium chloride and water. This is called salt. Okay. And because this reaction is with strong acid and strong base, and they are going to neutralize each other. So we call it neutralization reaction. Okay, and the salt form will be the neutral salt. Neutral salt means if you are going to dissolve that sodium chloride in the water, it will not change the color of pH paper. So it will be the neutral salt. Okay. And if you have, here you have strong base and strong acid. If you have situation like this, sodium hydroxide and this sort of situation, you have strong base and weak acid. This reaction will give you this sort of salt. Now this salt, because this salt is formed from the reaction of weak acid and strong base, so this will be the basic salt. Basic salt means when you are going to dissolve this salt in the water, it will change the color of pH paper into blue. So it means this salt has the ability to change the color of pH paper into blue, and blue color indicates the solution which you have dissolved in water, which you have the solution which you have actually, it is a basic nature. Similarly, if you have HCl and NH3, it will give you NH4Cl. Now here this is strong acid, and here you have weak base. It will give you the salt which will be acidic in nature. Okay. Mean this salt, ammonium chloride, is formed from weak base and strong acid. Okay. So these are some reactions of acids and base titration curves. In titration is a process actually we used to do in the laboratory, where you have to titrate, means you have burette. We will perform that experiment hopefully next week, where you are going to actually make a graph in pH versus titrated solution. Okay, volume titrated solution, basically the volume of titrated solution. Suppose here you have pH and here you have volume of base NaOH, and you are going to titrate this base with an acid. Suppose you are dealing with such type of reaction where you have sodium hydroxide and HCl. It will give you sodium chloride and water, and you are going to study this reaction using titration method. Here you have sodium hydroxide, volume of NaOH, added, and in the reaction mixture you have a base. Okay, this is a strong base, strong acid, and here you have strong base. Now what will happen? You have strong base and then strong acid. You are going to titrate. Here you have pH scale 0 to 14, here you have 7. Because in the reaction in the conical flask you have acid. Now you are going to titrate acid with base. Initially you have acid, and if it is strong acid, its pH will be lower. It will start from here, and after some time it will increase, and then it will be like this. Because after titration, at time initially you have strong acid, and when you are going to titrate with volume of NaOH, you are going to add actually some quantity of sodium hydroxide. It will increase the pH, and at some point there will be a neutral solution, neutral mixture, because at that point the number of moles of sodium hydroxide will be equal to the number of moles of HCl. That point will be near to 7. That is called equivalence point. Okay, and after this point, you are going to add more and more sodium hydroxide, then its pH will be increased. And because you have strong base, and strong base are those bases which have pH near to 40. Okay, and if you have, we will study only two types of volume of NaOH added. Here you have 7, 14, 0. If you have weak acid, suppose such type of reactions, for example this one and this one, such type of reaction you will come up with this and what. If you do to study such type of reaction, here you have weak acid and strong base. Now you have weak acid in the flask. Weak acid are those acids that usually have the pH in between 0 and 7 or near to 7. Suppose it's weak acid, so it will give you like this. Because it is a weak acid, okay, weak acid usually have pH less than, greater than 2 or 3, or they are near to 7, as compared to this curve. This is strong acid and this is weak acid, it will give you like this. And after some points, it will pass through some neutral pH, and then because you are going to actually add the volume of sodium hydroxide, it will give you finally the solution with stronger base, because its pH will be high. Okay, so you can also make a curve with the change in concentration of acid. If you have strong acid, your curve will be like this. If you have weak acid, your curve will be like this. If you have more weaker acid, and your curve will be like this. Okay? Suppose this is acid A, this is acid B, this is acid C. So from the curve you can see A is stronger acid, then B is stronger acid, then C. Okay, A is stronger acid, B is weaker than A, and B is greater than C, whereas C is weaker than B and O. Okay, these are the titration curves. Okay, so today we have studied the concept of acids, different concepts to explain the concept of acid and bases. Then we studied the strength of acid and bases, what are the strong acids, what are the weak acids, and similarly the concept of stronger and weaker bases. And then how will you actually measure their strength by using pH paper, pH meter, okay? And then we have studied the titration curve.